So in all the demos, you have seen that you can connect to various services using various routing rules, and virtual service is the one which provides that. But one of the things that we could not do was connect to the service from outside. So whatever demo we did, it worked only within the service mesh, meaning from one pod to another. We could not do it from the node, neither we could do it from outside of the cluster completely. What is Istio Gateway? It provides you just that. You can connect to your service mesh from outside of the cluster. So it is an entry point to the cluster. So let's say this is a Istio service mesh, and these are the two pods that we have. It can be a deployment also. Pod 1 has application container 1 with an envoy proxy. Pod 2 has application container 2 with envoy proxy. And these are the services that we have created for these two pods. Now what we did a curl using the FQDN or fully qualified domain name of the service from the node itself. It went to hcresolve.com. From there, it got the information of core DNS or kubedns server. So got the IP address or the cluster IP address of the service and then connected to the service. And from the service, it connected to the pod. And it completely bypassed envoy proxy. So that's why when we were trying from the node, it was not working. The routing rules that we had mentioned using virtual service were not working at all. And this is the reason, because it was bypassing the proxy altogether. When the same curl command was used from the pod itself, it went to envoy proxy, got the routing rules, and based on the routing rules, it forwarded the traffic to itself or to the other service. So that's what we did using app and app2, or ABV1 and ABV2 in the previous demos. And also we spread traffic using 80% and 20%, 50%, 100, 0%, etc. So you can do various elegant canary releases using this. So what was the problem? You already know that we cannot connect to the service mesh from outside of the mesh. So let's say we have a application with front-end, back-end, and database tier. So how do you connect to the front-end from external world? So this is our Istio service mesh, and we have implemented front-end and back-end in the service mesh. And we need to connect to the front-end service from an external server or browser. Similarly, the database is outside of the service mesh, and from the backend application, we want to connect to the database, which is again outside of the service mesh. So how do you do it? Because so far, we have only been able to communicate across nodes within the service mesh only. So this is where gateways come into picture. So there are two types of gateways: ingress gateway and egress gateway. So ingress gateway is for entry into the service mesh, and egress gateway is for exit from the service mesh. So now the external server or browser can connect to the application in the service mesh using ingress gateway, and the same is true for egress gateway also. So backend application can connect to the external database, which is outside of the service mesh, using egress gateway. Now these ingress and egress gateways are standalone envoy proxies. That means they are running as pods, and only one container is running, that is Istio proxy or envoy proxy. Nothing else is running in this gateway containers. So these envoy proxies are facilitating us to provide these gateways. One is incoming gateway and the other one is outgoing gateway. Now the advantage of having envoy proxies is that we can create virtual service and destination rules and attach those routing rules using virtual service and destination rule to these envoy proxies. So it not only gives you an inroad and exit from the service mesh, it also lets you use very elegant routing rules using virtual service and destination rule. So now what will happen is that the server browser and these backend application will connect to the database via the proxies. Now all the virtual service routing rules would be applied to the proxies. So the question is, how do you implement? So before proceeding further, I have to tell you that Istio already provides one. I have already shown you that, but let us go ahead and see that again. So I am in my cluster. If I do a kubectl get pods in Istio system namespace, and you see that these are the two pods that are running, Istio egress gateway and and Istio Ingress Gateway. As of now, there are only one pods running. You can of course have multiple. So these pods must have been deployed using a deployment, and these are the deployments: Istio Egress Gateway and Istio Ingress Gateway. So these two deployments are running these two pods. So these are the gateways. One is incoming and the other one is outgoing, which is already provided by Istio system. So it is provided by the Istio installation. We did not have to do anything. We just had to install Istio, and we already got one from the installation itself. Does that mean we cannot create any more ingress or egress gateways? Of course we can. We can create custom ingress and custom egress gateways also. Now let's see the service. And these are the services, and for Istio egress gateway we have a cluster IP. These are the mapped ports, and for Istio ingress gateway the service type is load balancer. Of course the external ID is pending because it has not been associated with any load balancer, which is provided by cloud services, and we are not running our cluster using any cloud service provider. So that's why even though the type is load balancer, the external IP is pending. It also gives us a cluster IP. So if you have to connect to the system from the cluster itself, we can use the cluster IP. But one interesting thing here, if you notice from here to here, so these are the port mappings. Now these are not cluster IP port mappings, these are node port mappings. So 15020 is the service port and 31592 is the node port. 80 is the service port and 31797 is the node port. 443 is the service port and 30583 is the node port, so on and so forth. So that means we already have a service pre-installed with node port type. So why we are getting node port? Because when you create a service with type load balancer, you get a load balancer and node port also. Basically load balancer plus cluster IP plus node port. You get all three service types. So we can go ahead and use this. And of course we can create our custom ingress and egress gateways also. Let's see the pod a little bit more. Let's do a describe of the pod. Alright, so this is the pod, and see the containers here. It is running only Istio proxy. I can scroll down and will not find any other containers in this pod. And there are some ports which are of course exposed, which I've already seen from the service. Scroll down, or no other containers that are running in this pod. So let's take a look at the egress gateway pod also. And in the egress gateway pod also we have this container which is Istio proxy, and the image is coming from docker.io/istio/proxy v2 for Istio version 1.5.1, and there's no other container running. So we know that there's a pod to run standalone Istio proxy container, which you have already seen, and if we have to implement our own, we have to have such pod as well. Then we have deployment for the ingress gateway, which is implementing or running this pod, and then we have service for ingress gateway to connect to the proxy. Otherwise, how do you connect? Now then we have to create something called gateway object. So currently the Istio ingress and egress gateway that we have seen are running there, but they are of no use. So we have to create something called gateway object, which will enable the ingress gateway to do the work it is supposed to do. So once we create the gateway object, then only the ingress gateway will be able to receive traffic from external world. And after that, we'll create virtual service to link the backend services and routing rules to the ingress gateway. Now we can do this because we have an envoy proxy running as Istio proxy in the deployment. Using virtual service, we apply these routing rules to ingress gateway also. So how does the YAML look like? Let's check the Istio documentation. And this is the link. You'll find the link in the resource section also. So you know how to go there. We have gateway. So in gateway we have two options. One is selector and the other one is server. So server has options. So selector, we have to mention the selector, that's it. But server has some options. So there are some examples given. Scroll down. And the options that we have to provide in server is port and then hosts and some TLS configuration. So we'll not do any TLS configuration. So port is of course the port number. I'm not going there, but there's something called hosts. So it says one or more hosts exposed by this gateway. We'll see what does that mean. Now, to create the YAML file, it is much more straightforward than virtual service and destination rule. You know the API version. The kind is gateway, metadata is straightforward. But in specification, we have selector, which is important. So what this selector does, it selects the pods that are running only the standalone Istio proxy or the envoy proxy. So here we have Istio is one of the label whose value is ingress gateway, and app is the other label whose value is Istio-ingress gateway. Now, which pod this is selecting. So as I told you that when we create or when you install Istio, we get an Istio ingress gateway by default from the installation, which you have already seen. So it is actually selecting that pod. Now, why do we have a selector? Because as I said, we can have custom ingress gateways also. It's not that you'll have only one ingress gateway, which is provided by the installation. You can have your own ingress gateway. So that's why while creating the gateway object, you are saying that you are enabling that particular pod, which is a sidecar proxy or envoy proxy, implemented as ingress gateway. Now, if we go back to the console and take a look at the labels of the pods, and if I can see, this is the pod we are looking for, ingress gateway. So these are the labels. We have app, Istio-ingress gateway, then you have something called chart, there's something called heritage, and then you have Istio equal to ingress gateway. There's this pod template hash, which you already know, then release and canonical name, and then some revision, which is 1.5. So most optimum to use would be app Istio ingress gateway and Istio ingress gateway. So the label would be app, whose value would be Istio ingress gateway. Another label would be Istio, whose value would be ingress gateway. So the moment you provide these two selectors in the gateway object, this pre-built Istio ingress gateway pod will be selected as part of that gateway object, and this pod will be enabled to accept traffic from the outside world. As I said, you can create your own custom ingress gateway also. For that, definitely you would want some different labels. Then the final option is servers, which is also important, which you have already seen. In port, you have number, the name of the port, and then protocol can be HTTP or TCP. Now finally, you have hosts. So what is this host? So it is familiar because you have seen this in virtual service. So you know how virtual service is implemented. So when you create a virtual service, that configuration is sent to all the envoy sidecars or all the envoy proxy containers. So when one app tries to connect to another app, or one service tries to connect to another service using the service FQDN or fully qualified domain name, it goes to the sidecar proxy and it finds out the mapping or finds out the routing rule in the sidecar proxy, because the routing rule was already set by the virtual service. Now the hosts that we used in virtual service was the fully qualified domain name of the service. Now here we should have domain names that would come from the external world. So what will happen is, as it will be implemented in a proxy, any traffic that comes for, let's say, deep.com, that this ingress gateway would be applied to that traffic. So that's what host means. So let's see this in a diagram, which will be more clear. So we have this Istio service mesh, and these are the two pods or two deployments that we are going to do. One is app pod and the other one is app2 pod. And of course they have envoy proxy and its own container, and they have app service and app2 service. So these are the ingress gateway pod, which is nothing but the Istio proxy, and then Istio gateway ingress gateway service, which is given to us by Istio installation. Then what we do, we create the gateway object. So the moment we create the gateway object, this service and this pod would be enabled to receive traffic from outside world. Now the question here is that from which hosts this proxy should receive traffic from. Of course, we have not mentioned the routing rules yet. We have to give the host information from where we are expecting traffic from. Otherwise, anyone can come and connect to your application in the service mesh. So that's what the hosts in gateway object does. It tells the proxy that whenever you receive traffic for that particular host, like in our case it is deep.com, then only get it and do further processing. And the further processing is enabled by virtual service. And in virtual service, we'll mention one more option called gateways. It is different than any other virtual service because we have not provided gateways in any other virtual services so far. But what happens here, the moment we create this virtual service with gateways keyword, it is only attached to this proxy. So this virtual service will not be sent to any other envoy proxies in the service mesh. Now, what do we do with the virtual service? Of course, we provide routing rules. Now, this routing rules, whatever we mention here, would be only applicable for the traffic that is coming from outside and trying to enter the mesh. It is not applicable, or these routing rules will not be applicable for the containers or services or pods that are running inside of the service mesh. So we have a host and virtual service also, which should map with the host and gateway object. Otherwise, this one will not work. So gateway object enables the ingress gateway pod to accept traffic, and virtual service with gateways keyword will provide the routing rule that is needed for this envoy proxy or for the ingress gateway. So now once the traffic comes, it will be sent to these services that we create. Now, of course, sending traffic to these services would be subjected to the routing rules that we have mentioned in this virtual service. Now, what if we want to have routing rules inside of the service mesh? That remains same. We have to create a separate virtual service, and that virtual service routing rules or configuration would be pushed to all the envoy proxies in all the pods of all the deployments in the service mesh.